Hey guys, I'm going to spend some time going over the day 6 notes. So today we're going to be looking at analyzing functions and graphs. Okay, so we can analyze parts of a function by describing them as increasing, like going up. So right here this is increasing, or decreasing, which would be like going down. Okay, linear, remember that means a straight line, or non-linear, that means it's not a straight line. Okay, so for this one, we're going to describe the parts of the function shown below. So part A says between x equals 0 and x equals 4. So you need to go to the x-axis where these red dots are. So between x equals 0, where my cursor is right now, to x equals 4, that's from here to here. So if I go to the line from here to here, this is increasing, and it's actually non-linear. I know it looks like it could be a little bit linear, but it's actually pretty curved right here. So this is increasing because it's going up, and it's not linear because it's not a straight line. Part B says between x equals 4 and x equals 8. So we go to the x-axis, we find 4 and 8, and from here to here, this is now going down, so it's decreasing, and that is also nonlinear because it's not a straight line. Okay, another example of something like this would be a distance versus time graph. This is actually something you'll learn about in 8th grade science as well. So a distance versus time graph shows us how far two objects are from one another. So consider what the following types of lines on a distance versus time graph would represent. So I'm going to look at each one. So part A. So this would be like 0 time and 0 distance. As time is increasing, distance is also increasing, because if you look at this line, as time is passing, the line is going up and up and up and up for distance. So an object is moving away because the distance is getting further at a constant speed because it's a proportional relationship. It's moving away from something at a constant speed as time passes. Okay? Now B. Here, the distance is really high, so let's pretend like, I don't know, we're standing at a stop sign, or this is our distance away from a stop sign. Okay, so this could be like we're 20 feet from the stop sign, and then we're 15 feet, and then we're 10 feet, and then we're 5 feet, and then we're 0 feet. Okay, because the distance is decreasing as the time goes on. So we're actually moving closer to an object at a constant speed because it's a straight line. Okay, and then for C, the distance from the object is not changing as time is passing. So let's say this is 20 feet from a stop sign is a starting point. We're still 20 feet, we're still 20 feet, we're still 20 feet, we're still 20 feet. The whole time you're not moving, you're just staying 20 feet away from that stop sign. Okay, so this one, I'm just going to keep using my distance standing from a stop sign example. So for D, when 0 time has passed, we're standing right at the stop sign. There's no distance between us and the stop sign. Now, as time is passing, we're getting further from the stop sign. And then as you can see, this is kind of going up faster and faster because we're getting further and further from the stop sign in less time. So here, we're getting further away from the stop sign in less time. This is more increase than it was down here. So we're moving away, and we're moving away faster because our distance is increasing in a short amount of time. Okay, now this one, we're moving away. At first, we're moving a lot of distance in a short amount of time. Then we're moving not as much distance in a short amount of time. So we're actually going slower. So this is moving away and decreasing in speed. Okay, so part 2 of the notes. Okay, match each distance versus time graph with the correct description. So this one would be B. Brennan and his dad left for school in his dad's car. They got stopped at the train tracks for several minutes before they were able to continue to school. Okay, so they're starting at home. This is kind of like starting at home, no time has passed. They're in the car and they're driving, they're moving away from their house. They're stopped at the train tracks, and then they're moving further away from their house towards school. Okay, now the second one, A. Kaylee got in a bus at her house. The bus made 2 more stops before it arrived at the school. So this is her starting at her house with no time passing. Okay, she gets on the bus. She moves away from her house, and then they stop to pick somebody up on the bus. She moves away from her house again, and then they stop for the second bus stop. And then she moves away from her house even more towards school. Okay, and then the last one, C. Cameron left for school with his mom, but remembered he left his English project at home. She took him back home to get his project, and then they headed back to school without any stops. So at the origin, he's starting at home and no time has passed. Okay, so he leaves, he goes further away from his house, then, he realizes he left his English project at home, so he actually goes back to his house. So his distance from his house is decreasing because he's going back home. Okay, now he's back home, and then he gets in the car, and then she's going to have to go a little bit faster to get him to school on time. So we're going away from the house. We're increasing our distance pretty quickly to get to school on time. Okay, the next one is where we were going to create a distance versus time graph showing Adam's distance from his house and label each segment of the graph. So, remember, this is distance from his house, from Adam's house. Okay, so Adam left his friend Brody's house and started walking home. So Brody's house is pretty far away. Obviously, 0 distance from his house is here. Brody's house is pretty far away. Okay, he starts walking to his house, so his distance from his house is decreasing a little bit. Then he realized he left his phone at Brody's, so he turns around and he goes back to Brody's, which is further away from his house again. Okay, Adam left Brody's again and started to walk home. So now he's walking back home. Okay, Adam stopped halfway to talk to a friend he passed. So here he has not changed his distance at all, and time is passing while he's talking to his friend. And then Adam quickly ran home in time for dinner. So then he ran home. His distance to his house gets less and less because he's almost there. Okay, same kind of idea again. Vanessa left her house to run at a steady jogging pace. So she starts here, she leaves her house, she's getting further from her house at a steady pace. She increased her speed, so she's getting further from her house in less time. She sat down and stopped to stretch, so her distance does not change. She's pretty far from her house, but she's just sitting there for a certain amount of time. Okay, and then she decided to turn around and walk back. So this is her distance from her house decreasing because she's walking back home. Okay, the graph below shows Justin's distance from his house as he walks to school. Interpret what you think happened at each segment of the graph. So your answers could be different, but so as he walks to school. So I would say that he leaves his house, he starts walking towards school at a steady pace. Then here he meets up with one of his friends, and they stop and talk for a minute, but then they both realize that they're running late, and so then they start walking again. They start walking, but then they start running faster and faster, and then they decide to race. So they're just running as fast as they possibly can towards the end because their distance from their house is increasing pretty quickly. Okay, I hope that helped. I know that these notes in particular would be kind of hard to understand without some extra help. So I hope that was helpful for you guys. Good luck.